Welcome back to another episode of Game Theory. Today we are in chapter 17, which is about bargaining. So, bargaining can also be modeled as a game. You think of the situation where a union and a company are making negotiations. The outcome depends upon not just what one player does, but on what both of them can agree to. Thus, there is strategic interaction, which means that our game theory tools are applicable. We will look at three models of bargaining in this chapter. The first is what's called Nash bargaining, or your book refers to it as Nash's cooperative solution. The other two models involve alternating offers. The players take turns making offers to each other. So in the first round, the company makes an offer. In round two, the union makes a counteroffer, and they just go back and forth until some agreement is reached. So in the first model, there is diminishing surplus. So as negotiations go on longer and longer, then that's going to reduce the benefits of working together. So as the negotiations between the company and the union drag on, then the benefits of getting a deal diminish because by then the factory has been idle for several months, and that's already cut into the firm's profits. So why I keep talking about unions? Well, when I first taught this class back in 2014, I was a grad student at the University of Oregon. At the time, the grad student union teachers were going on strike. I did not participate. I thought the position was not terribly a good one that the grad students took. They were talking a lot about the healthcare benefits. If you're a grad student, you're probably 20s, maybe early 30s in good health, so healthcare is not a huge concern for you. This was back in 2014, long before anyone worried about the coronavirus. So I wasn't quite sure I put in so much focus on healthcare benefits instead of things like wages, which is useful no matter how good or bad your health is. So I didn't participate, but it did provide some excellent motivation for the material in this chapter when I taught the class back then. And the last model, which I wrote over down here, is alternating offers with impatience, a different way to model the decreasing benefits when the negotiations just drag on. So we'll look at Nash bargaining first. One key element in Nash bargaining is you have to know what could the players secure for themselves if no deal is reached. So if, say, the grad students end up going on strike and they don't come back, what's their alternative? How much money could they get from welfare? That'd be one consideration. If the university fails to get the grad students to agree to a deal and have to go without any grad student TAs, how much damage does that do to them? How much harm does that impose? That's going to be an important consideration in the university's decision about the negotiations. You think about this with job offers as well that are individualized, not just with a union. So if you're talking to an employer about salary, one thing you think about is how much money could I get if I take a different job instead? Similarly, the employer is thinking about how much would it cost us to hire somebody else to do the same job. So everyone's thinking about what could I do if no deal is reached? What's my alternative? So let's introduce some notation. So A and B are negotiating, so this could be the university and this could be the union or something like that. And we're trying to allocate something, we're trying to allocate some amount of money. Let's say we're trying to divide up V. So V is the value of what we're trying to split up. So V for value. So this notion here of what can I get if I don't get a deal, that was a name, and that name is BATNA. So that's an acronym for B is for best, A for alternative, T for two, N for negotiating, and A for agreement. So an example I faced almost a year ago. I was working for Truman State University at the time in Missouri, and I had an offer from them to renew the contract. I also had an offer from Binghamton University to start working here. So I made some negotiations with Binghamton University over what my salary was. In those negotiations, my BATNA was how much money I could have gotten if I had stayed at Truman State. So if we fail to reach a deal on what my salary would be at Binghamton, then I say I'm just going to stay at Truman State. So that'd be my alternative to working here. And Binghamton presumably had their own BATNA based on what they think they could have gotten someone else to accept for doing the same job. There were other job candidates out there who were applying. So for notation, person A's BATNA is going to be lowercase a, and B's BATNA will be lowercase b. So for negotiations to make sense, we have to have V greater than A plus B. There's got to be more value from working together than from working separately. Otherwise, you just work separately and there's nothing to negotiate over. So, for example, maybe A and B here are two musicians. They could work together and form a band. If they do so, they got to come to some agreement on how they're going to split the band's revenues. So if they think the band is going to be more profitable than each of them could get individually, maybe the band was going to bring in, I don't know, $1 million, but they can get only 100,000 each if they work separately, then there's a big benefit to working together. In that case, there's going to be an incentive to negotiate. On the other hand, this is not true. If the band can only get them 150,000, but they could get 100,000 each by staying separate, then it's better just stay separate. There's nothing to study in that case. So that's why this will be the more interesting scenario. So we define surplus to be the total value minus the BATNAs. So those are the extra benefits from working together. And for some further notation, VA is going to be the total amount of value, V, that goes to person A. And similarly, VB is the amount, the total value that B gets. So what that implies is that if there are only two people involved, then those have to sum to the total value. Other notation, we'll let PA be the fraction, not of the value, but of the surplus that goes to person A. So be a little bit careful here. That's the reason why I gave that some emphasis. Oftentimes when students make mistakes in these problems, it comes from confusing total value with surplus. So the total value is just the total amount of money that's being divided up. The surplus is that amount after you subtracted the BATNAs. So they're not the same thing. PB is going to be the fraction of the surplus that goes to person B. So because these are proportions, we know that they have to sum to 1. So the first insight here in Nash bargaining is that each player must get at least their BATNA in any negotiation. If you don't get at least your BATNA, then you're going to refuse the deal and it's better to work separately. So like when I was negotiating with Binghamton, my BATNA was what I could have earned from working at Truman State. If my salary here was not at least as large as what Truman State was offering, I would have refused. I would have gone to Truman State instead. Or I should say I would have stayed at Truman State because I was already there. So after you each play their bat number, there's a surplus because working together is better than staying apart in these examples. So after you've gotten at least your BATNA, then you get some part of the surplus as well. Which brings us to the following. So the total amount that person A gets is their BATNA plus some fraction, which we define as PA, of the surplus. Similarly, for person B, they get their BATNA and their fraction of the surplus. And that is Nash's solution. So the most obvious solution, I think this one that Nash had in his original paper, was set PA and PB equal to each other, appealing to symmetry. However, the results were then generalized to realize that PA and PB could be anything between 0 to 1, so it doesn't have to be just half. It doesn't have to be equal division of the surplus. Now, to be clear, if you do impose PA and PB being equal, that does not necessarily mean each player gets the same amount. It means they get the same fraction of the surplus. But remember, you guys also get your BATNAs on top of that. So the BATNAs are different. The total amounts the players get will be different, even if they're splitting up the surplus evenly. Let me put together a quick example to illustrate that. So let's say a total value is 20, and person A's BATNA is going to be 10. and person B's BATNA is 2. So that means that person A is going to get their BATNA of 10 plus some fraction of the surplus. So the surplus here is going to be 8. Let's find what person B gets. So person B is getting their BATNA plus their share of the surplus So that's the general solution. If you want to impose PA and PB being equal, which again you don't have to, but if you do impose that, sharing the surplus equally does not imply equal outcomes. So in that case, person A gets 14. So person B would get 6. So that's how Nash bargaining works. Now, there is a potential objection here. It's very hard to refute Nash bargaining because it seems very, very reasonable. Each player gets at least their BATNA, which seems perfectly logical. Otherwise, they would walk away. The issue, though, is that because PA and PB could, in general, be anything from 0 to 1, it imposes very few restrictions on what is possible. So it gives you a very, very wide range of potential outcomes, so very little predictive power. So as a result, we look towards other bargaining models that give us more precise predictions. So to learn more about those, be sure to join us for our next episode.